Picture this. The year is 2025, a time when technology has seamlessly integrated into our daily lives. A robot barista whips up your double-shot macchiato flawlessly. It's a sight to behold. No spills, no fuss, just pure caffeinated bliss. The precision is almost magical. You might not realize it, but behind that perfect cup lies a hidden world of intense robot training. It's a meticulous process. These mechanical marvels don't just magically appear fully equipped to navigate our world. They have to learn, adapt, and evolve. For years, robots were confined to cages, repeating the same tasks endlessly. Their world was limited. Think factory assembly lines, not bustling coffee shops. Their roles were monotonous and unchanging. But things are changing. Fast. The landscape of robotics is evolving at an unprecedented pace. AI is enabling robots to learn in ways we never thought possible. They are becoming more autonomous and intelligent. They are breaking free from their repetitive routines, exploring new horizons. They are tackling complex challenges, from solving puzzles to navigating intricate environments, and they are doing it all by learning for themselves, through self-learning and advanced algorithms. This isn't science fiction, folks, it's happening right now. It's the reality of AI robot training, a fascinating blend of technology and innovation. It's a captivating journey of algorithms, simulations, and a dash of trial and error, each step bringing them closer to perfection. Get ready to peek behind the curtain and discover the secrets of how robots are learning to navigate our world. The future is here, and it's more exciting than ever. Imagine a virtual world, a digital replica of our own. This is where the robot revolution begins. In these simulated environments, AI robots take their first tentative steps. They learn to walk, grasp objects, and even interact with their surroundings. All without ever setting foot in the real world. Think of it like a video game, but for robots. These virtual playgrounds are carefully crafted to mimic the complexities of our physical world. There are obstacles to overcome, tasks to complete, and even unexpected surprises thrown in for good measure. Why the need for a digital boot camp? Well, imagine letting a clumsy robot loose in a china shop. Not pretty, right? Simulations allow robots to learn from their mistakes without any real-world consequences. They can drop 1,000 virtual cups before mastering the art of a steady grip, all without shattering a single piece of digital porcelain. Now, let's talk about motivation. Robots, unlike humans, don't respond to pep talks or gold stars. Their learning is driven by something far more powerful: algorithms. Specifically, something called reinforcement learning. Imagine a robot dog learning to fetch. Each time it successfully brings back the ball, it receives a digital reward. A little jolt of algorithmic joy, if you will. Make a wrong move, and the reward disappears. This constant feedback loop of rewards and penalties helps the robot learn which actions are desirable and which ones to avoid. It's like teaching a dog new tricks, but instead of treats, we use lines of code. The beauty of this approach is that robots can learn far more complex tasks than simply fetching a ball. They can learn to navigate intricate mazes, operate machinery, and even play a mean game of chess. All thanks to the power of algorithmic encouragement. After countless hours in the digital playground, it's time for our robot trainees to face the ultimate test, the real world. This is where the rubber meets the road, where simulations give way to the unpredictable chaos of reality. Remember that perfectly poured latte we talked about? Getting there requires more than just virtual practice. Robots need to learn how to operate in messy, unstructured environments. They need to contend with spilled coffee beans, chattering customers, and the occasional rogue napkin blowing in the wind. This is where things get really interesting. Researchers intentionally throw curveballs at these robots, forcing them to adapt and learn on the fly. They create unexpected obstacles, change the environment, and even introduce new variables to the equation. It's all part of the plan to create robots that are not just competent but truly resilient. Humans learn by watching and imitating. We observe, we mimic, we master. Now robots are getting in on the act. Through a fascinating technique called imitation learning, robots can learn by observing and copying human actions. Imagine strapping on a special suit equipped with sensors and having a robot shadow your every move. As you demonstrate a task, the robot records your movements, analyzes your actions, and then attempts to replicate them. It's like having a robotic apprentice that learns by your example. This approach has incredible potential. Imagine robots learning complex surgical procedures from world-renowned surgeons, or mastering the delicate art of painting by imitating the strokes of a master artist. The possibilities are as limitless as human ingenuity itself. Here's where things get really mind-blowing. We're on the brink of a technological revolution that will change the way we think about artificial intelligence and robotics forever. Imagine a future where robots don't just learn in isolation, but share their knowledge and skills across a vast, interconnected network. This means that every robot, no matter where it is in the world, can benefit from the experiences and learnings of others. This isn't some far-fetched fantasy, it's the next frontier of AI robot training. Engineers and scientists are already working on creating these networks, where robots can communicate and learn from each other in real time. Imagine a robot in Tokyo learning a new skill, say folding laundry with unmatched precision. This robot doesn't just keep this knowledge to itself. Now imagine that knowledge being instantly uploaded to a shared network, accessible to every other robot on the planet. This means that the moment one robot masters a task, all robots can perform it just as well. Suddenly, a robot in Paris can fold laundry with the same finesse as its counterpart in Tokyo, without ever having to go through the tedious process of learning from scratch. This seamless transfer of skills can save countless hours of programming and training. This interconnected future of robot learning has the potential to revolutionize countless industries. From manufacturing to healthcare, logistics to domestic chores, the applications are endless. Robots could learn from each other's successes and failures, constantly refining their skills and pushing the boundaries of what's possible. This continuous improvement loop will lead to more efficient, capable, and intelligent machines. It's a future where knowledge is shared freely, and the pace of innovation accelerates at an unprecedented rate. The possibilities are truly limitless, and the impact on our daily lives could be profound. The world of AI robot training is a fascinating journey into the heart of artificial intelligence. It's a realm where machines are not just programmed, but are taught to learn, adapt, and evolve on their own. This journey begins in controlled environments where robots are exposed to a variety of tasks and challenges designed to test and enhance their capabilities. From virtual playgrounds to real-world challenges, robots are constantly learning, adapting, and evolving. They navigate complex environments, solve intricate problems, and perform tasks that were once thought to be the exclusive domain of humans. This continuous learning process is what makes AI robots so unique and powerful. As they become more sophisticated, they promise to reshape our world in profound ways. Imagine robots that can perform surgeries with precision, assist in disaster recovery, or even explore distant planets. The potential applications are limitless, and each advancement brings us closer to a future where robots are an integral part of our daily lives. Imagine a future where robots seamlessly integrate into our lives, assisting us with everyday tasks, providing companionship, and even pushing the boundaries of human knowledge. They could help with household chores, offer support to the elderly, and provide personalized education to children. The possibilities are as vast as our imagination. It's a future full of exciting possibilities, but it also comes with its own set of challenges. As we push the boundaries of what robots can do, we must also consider the implications of their integration into society. How will they impact our jobs, our privacy, and our security? These are questions that need careful consideration. As we create robots capable of learning and adapting, we must also grapple with the ethical implications of their existence. The power to create intelligent machines comes with the responsibility to ensure they are used for the benefit of all. This means establishing guidelines and regulations to govern their development and use. How do we ensure these intelligent machines remain tools for good? How do we prevent them from being used in ways that could harm society? These are critical questions that require input from a diverse range of stakeholders, including scientists, ethicists, policymakers, and the public. How do we navigate the evolving relationship between humans and machines? As robots become more capable, the dynamics of this relationship will inevitably change. We must find ways to collaborate effectively, ensuring that robots complement human abilities rather than replace them. These are questions we must confront as we venture into this brave new world of robotic potential. The decisions we make today will shape the future of AI and its role in our society. It's a journey filled with promise and uncertainty, but one that holds the potential to transform our world for the better. One thing is certain, the future of AI is filled with wonder, and how we choose to shape it will define the course of humanity for generations to come. The possibilities are endless, and the journey has only just begun.